Class 9th Maths Chapter 2 Polynomial Exercise 2.1. Students, today we will solve all the problems given in the exercise 2.1. Let us start from question number 1, which is: which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. Now let us have a look on the expressions which are given. There are 5 parts of this question. First part, second one, third, fourth and last one. In the first part, we are given 4x square minus 3x plus 7. Let us write down this expression: 4x square minus 3x plus 7. Here in the question we are asked two things. First of all, whether the expressions are polynomials. Suppose we have taken this first part, we have to find that whether 4x square minus 3x plus 7 is a polynomial. And the second part of this question is which of them are a polynomial in one variable. First of all, we will find that whether this expression is a polynomial. When we have discussed about polynomials, I have discussed that there are three main characteristics of a polynomial. These characteristics makes an expression, or we can say an algebraic expression, a polynomial. Let us see which are those characteristics. Number one, the number of terms should be finite. The number of terms should be finite. Second condition, the exponent of a variable must be a whole number. Exponent of any variable must be a positive number, or we can say a whole number. Number three, coefficients of the variable should be real number. Let us find these characteristics in this expression. Here the number of terms are 1, 2 and 3. So the number of terms should be finite. This condition is fulfilled by this expression. The another characteristic, the exponent of a variable. Let us find the variable in this expression. In this expression, x and x square. Only the variable is x, and here it is x and here it is x to the power 2. Here in this term, the degree of x is 2 and here it is 1. Both are positive integers and we can say both are whole numbers. So the second characteristic to be a polynomial is also present in this expression. Now we have to find the third one, which is the coefficients of a variable should be real numbers. In 4x square, the coefficient of x square is 4, and in this term minus 3x, the coefficient of x is minus 3, and in this term we can write it as x to the power 7x to the power 0. In this term the coefficient of x is 7. So 4 minus 3 and 7 all are real numbers. So we can say that 4x square minus 3x plus 7 is a polynomial. Now it is clear that 4x square minus 3x plus 7 is a polynomial. Now we have to find that whether this polynomial is in one variable or not. You can see here x square, the variable is x. Here 3x minus 3x, the variable is x, and no other variable is present in this expression. So the polynomial is in one variable, and that is x. Now the second part of this question is y square plus root 2. We have to find that whether this expression is a polynomial, and if it is a polynomial, then we have to find that whether this polynomial is in one variable or not. Let us see. We have to check out that whether the expression is a polynomial. To be a polynomial, this expression has to satisfy three characteristics. First characteristic is the number of terms should be finite. The second one is the exponent of a variable should be a whole number. It means it should be 0, 1, 2, 3, 4, and so on up to infinity. The third one is the coefficient of a variable must be a real number. Now let us check the characteristics of a polynomial. In this expression there are two terms. The number of terms are 2. So it is finite. The first condition is fulfilled. The second one, the exponent of a variable must be a whole number. Here the variable is y and the degree of y is 2, which is a whole number. The characteristic which states the exponent of a variable must be a whole number is also fulfilled by this expression. Number third, the coefficient of a variable must be a real number. Here the expression is y square plus root 2 and the coefficient of variable y square is 1, which is a real number. So all the three conditions are fulfilled by this expression. So the expression is a polynomial. Again, in y square plus root 2, we have a single variable which is y. Then we can say the polynomial y square plus root 2 is in one variable. Question number 1, third part, 3 root t plus t root 2. We can write this expression as 3 t to the power 1 by 2. We can write root symbol as a power 1 by 2. So here we can remove this root symbol from t and we can write it as t to the power 1 upon 2 plus root 2 t. The variable is t. We can write t root 2 as root 2 into t. So 3 t की power 1 by 2 plus root 2 t. We have to check the characteristics of a polynomial, in which the first one is number of terms. Here we have two terms, so the number of terms is finite. Again, we have to check the exponent of a variable or degree of a variable. Here the variable is t, and in this term it has its power 1 by 2, which is not a whole number. So the second characteristic of a polynomial is not fulfilled by this expression, so this expression is not a polynomial, although it is in one variable, but this one is not a polynomial. Here the power of variable, power or exponent, both can be used. Exponent of a variable is not a whole number, so this is not a polynomial, although the expression is in one variable. Let us solve the next problem. Y plus 2 upon y, we can write it as y plus 2 into y to the power minus 1. We have earlier discussed about this. When a variable is carried out from denominator to numerator, the sign of its power will be reversed. Here we are seeing that there are two terms, but the exponent of variables in first term here it is plus 1, but in the second term it is minus 1, and because variable has its power or exponent as a negative integer, so it is not a polynomial. Because the variable has question number 1, fifth part, we are given x to the power 10 plus y to the power 3 plus t to the power 50. Here we are seeing that the variables are x, y and t. There are variables as x, y and t. The number of variables are 3. The coefficient of variable in each term is 1. It can be written as 1 into x to the power 10 plus 1 into y to the power 3 plus 1 into t to the power 50. So the coefficient of x is 1, the coefficient of y is y to the power 3 is 1, the coefficient of t to the power 50 is 1. Coefficients are real numbers. There are three variables and exponent are in plus sign. Here it is plus 10, plus 3 and plus 50, which is whole numbers. The number of terms is 3, which is finite, so this one is a polynomial. But it is a polynomial in three variables, which are x, y and t. Question number 2. Write the coefficients of x square in each of the following. The given problem is 2 plus x square plus x. We can write it as x to the power 2 plus x plus 2 in decreasing order of the powers of the variable. Again, it can be written as 1 into x to the power 2 plus 1 into x plus 2. You can see that the coefficient of x square is 1. So, the answer will be the coefficient of x square in the given expression is 1. This is our answer. Question number 2, second part. We are given 2 minus x square plus x to the power 3. We can write it as x to the power 3 minus x square plus 2. Here again we can simplify this as 1 into x to the power 3. X to the power 3 can be written as 1 into x to the power 3 minus x square can be written as 1 into x square plus 2. Here we have asked for the coefficient of x to the power 2. So here the coefficient of x to the power 2 is minus 1, and this will be our answer. Third part of question number 2 is pi by 2 x square plus x. We have to find the coefficient of x square. We can write it as pi by 2 into x square plus x. Here we have the coefficient of x square is pi by 2. Here the coefficient of x square is pi by 2. Fourth part of the question number 2, we are given root 2x minus 1, which can be written as root 2 into x minus 1. Here we can see that there is no x to the power 2. If we have to introduce it, then we can write it as 0 into x to the power 2, because there is no x to the power 2, because no x square, and we have to introduce it, we have to multiply it by 0. And we know when we multiply any number, any term, any algebraic expression by 0, the value of that number, that expression will be 0. And here 0 into x square will be 0. So in this expression there is no x square. We have added it as 0 into x square. So the coefficient of x square in the expression is 0, and this will be our answer.